Today we're going to look at 3.2 on adding and subtracting polynomials. In this section, you're going to be able to add and subtract polynomial expressions. And so these are under the same standards that we looked at in 3.1 on adding, subtracting, and multiplying polynomials, and understanding that polynomials are closed under those operations, and being able to interpret the meaning and coefficient of coefficients, factors, terms, and expressions based on real-world context. And then create and solve equations and inequalities in one variable that model real-world problems and be able to interpret those solutions and determine if they're reasonable or not. And so we're looking at a couple examples today on how we add or subtract polynomials. So let's go ahead and look at what we need to see. So to add or subtract polynomials, we have to remember, like we talked about in 3.1, that we can only add or subtract like terms. Remember that like terms are ones where the variables and their powers are the same. And so we have two ways to show adding and subtracting. We can either do this horizontally or vertically. And think about like going back to first, second grade math, right? We could add 2 plus 3 this way and get 5, that's horizontally, or we can go 2 plus 3 vertically and get 5. Now, when we think about it vertically, we have to make sure we line up place values. Well, we don't have place values in polynomials, but we do have degrees of terms. And so we have to make sure those like terms line up together. And so let's look at example A and see how that's done. So in example 1A, we have 2x squared plus 5x minus 7 plus 3 minus 4x squared plus 6x. And so if we're going to add this horizontally, we're just going to look at like terms. And because we're adding, we don't need to worry about any sign changes. We just add like terms. We can actually drop all the parentheses and just go 2x squared plus 5x minus 7 plus 3 minus 4x squared plus 6x. And we're going to combine those like terms. So we have a 2x squared and a minus 4x squared. So 2 minus 4 is negative 2. And so we're going to get negative 2x squared. And then we look at our next like terms. And we've got a positive 5x and a positive 6x. So positive 5 plus 6 is 11. And so we'll have plus 11x. Finally, we go to our third term. We have the negative 7 and the positive 3, both those constants. And so negative 7 plus 3 is negative 4. And so we'll have minus 4. Now, is this in standard form like we talked about in 3.1? Yeah, it is. We have our degrees going from highest to lowest, second degree, first degree, constant. And so we have this in standard form, and it is completely simplified. And so that's how we do it horizontally. Let's look at example B, and we're going to look at how we do it vertically. So in example B, when we do it vertically, we have to make sure that the place values line up. Now, we do have a plus sign here, and so we're safe in adding these together. There's no sign changes going to happen to us. We just need to add the like terms. And so I've got y to the fourth. There's no y cubed term. There's no y squared term. My next term is a y term, and then I have a plus 7. And I'm leaving spaces for potential terms in the second polynomial. And so when we look at that second polynomial, well, I've got 2y cubed, so that's going to be here, and that's a positive, plus 2y, again, lining up what belongs to each other, minus 2y to the fourth, and then minus 11. And so we're adding all these together, so y to the fourth plus negative 2y to the fourth. So remember, there's a 1 here. 1 plus negative 2 is negative 1y to the fourth. There's nothing here, plus a 2y to cubed, so the 2y cubed will just come straight through. There were no y squared terms at all, so we can move on. Negative 3y plus positive 2y, so that's negative 1y. And then 7 plus negative 11, that's negative 4. Now we can get rid of the gap in the middle, and if we had any sign issues or if it wasn't in standard form already, if we hadn't already set it up in standard form, we want to put it in standard form. And so negative y to the fourth plus 2y cubed minus y minus 4. That is the simplified polynomial there after adding them together. Okay, so we can do this horizontally, we can do it vertically. Either method will work. It's just personal preference on what you want to do. Really, it comes down to how easy is it to see those like terms. Can we move them around, or can we write it vertically and just get the place values, the like terms, essentially with the same powers and the same variables to line up and add together, or subtract, and that's what we're going to look at in example 2 here in a moment. But I want you to look at example C, and I want you to try that one on your own. You can either do it horizontally or vertically, and I want you to pause the video at this point and add this together. Okay, so pause the video now. All right, so you should have paused the video, and if you didn't, go back and do it right now. But here is C worked out. I'm going to work it out vertically, lining up everything that we have. And so I've got a 4, and that's positive. There's a negative 2a and a 2a squared. From the second polynomial that we're adding, we have a 3a squared minus 8a plus 7. And so again, we're adding vertically all those like terms lined up. And so 4 plus 7 is 11. Negative 7a plus negative 8a, sorry, negative 2a plus negative 8a is negative 10a. And then 2a squared plus 3a squared is 5a squared. And so we get this polynomial, and it is already in standard form, and we're already pushed together. So 5a squared minus 10a plus 11. So we've got our simplified polynomial there. All right, so for addition, it's pretty straightforward because the signs aren't going to change on us. There's no crazy things happening. But when we go to subtraction, we've got to keep something in mind, and that's what we're going to look at next. So to subtract polynomials, we got to remember one of two properties. We either need to remember the distributive property, and remember the distributive property is that if I have a times b plus c, the a distributes in, and we get ab plus ac. But with subtraction, we actually have a negative sitting out there, and then like our b plus c here, and our negative will distribute to both, and we get negative b minus c. So those signs will change. Or we need to remember the definition of subtraction. And the definition of subtraction is that a minus b is just the same as a plus the opposite of b. And so if I have a polynomial, I can distribute that negative in, just like we did with the distributive property, to all the terms, and then change the operation from subtraction to addition. And we're going to look at that in the first two examples, how to use each property to solve this out. So in example 2a, I'm going to use the distributive property to distribute the signs and then combine like terms. And I'm going to do it horizontally. So let's look at example 2a. So in example 2a, we've got 3 minus 2x plus 2x squared minus, and remember there's parentheses here, 4x minus 5 plus 3x squared. And so using the distributive property, I'm going to distribute this negative sign to all the terms in the second parenthesis. And so anything that's positive will become negative, and anything negative will become positive. And so rewriting the next line, we get 3 minus 2x plus 2x squared. Nothing in that first parenthesis changes signs because the negative's not touching it. But all of these will. And so we're going to get negative 4x plus 5 minus 3x squared. And so again, everything in that second parenthesis has changed its sign. And now we can combine our like terms. And so again, you can highlight, you can underline, do something to identify these like terms. Well, our highest power is 2, so I've got a 2x squared minus 3x squared. And so that's going to give us a negative 1x squared. We'll go on to our x terms. And so I've got a negative 2x and a negative 4x. So negative 2 minus 4 is going to give us negative 6x. And then finally, going on to the constants, we've got 3 and we've got plus 5. So 3 plus 5 is 8.
And we can simplify the negative 1 in front. We don't need that. And so negative x squared minus 6x plus 8.
That is the simplified polynomial for this question. And again, we've distributed that negative out to everything in the second parenthesis. In example B, we're going to look at how we deal with changing the subtraction into addition. So let's go ahead and look at that. So typically when we use this method of changing subtraction to addition, we want to write it vertically and keep everything lined up and keep our signs available to us. And so that's how I'm going to write it out. And so doing the first binomial, or the first polynomial, 4x cubed minus 3x squared plus 6x minus 4. We're then going to change our operation from subtraction to addition, and that's going to cause every sign in the parenthesis to change its sign. And again, it's just like distributing this negative to all things in the next parenthesis. And so we're going to be adding 2x cubed minus x squared plus 2. So again, all the signs have changed in the second half of this problem. And so now we're able to add these, and we're adding vertically here. And so negative 4 plus 2 is negative 2. 6x plus nothing, well, that's a positive 6x. Negative 3x squared plus negative 1x squared, so that's a negative 4x squared. And then 4x cubed plus 2x cubed is 6x cubed. We've got this in standard form. We don't need to bring it all together because it's already together. And so this is our simplified answer. Again, so we can either distribute that negative in and just combine our like terms, or we can do it vertically and change this to addition. Again, your preference on which method you want to use, just make sure you're doing the right steps. And so in example C, I want you to try this one again on your own. So take a moment and pause the video to complete this problem. So go ahead and pause it now. All right, so you should have paused the video. If you didn't, again, stop it now and go back and do it. But let's go ahead and look at C. Again, my personal preference is to rewrite this. And so I'm going to distribute this negative, change it to addition. And so I'm going to get 3c cubed plus c squared minus 5c over, well, not over, but we're adding and distributing the negative. We're going to get a positive 8c squared. Let's put that in the right spot. Not there. Plus 8c squared, and then minus 3c cubed. And so let's see what happens. 3c cubed plus negative 3c cubed. Well, 3 plus negative 3 is 0c cubed. We'll talk about that in a second. We'll simplify it. Next, c squared plus 8c squared. There's a 1 right here. So plus 9c squared. And then negative 5c plus nothing is negative 5c. But let's go back to the front of this. 0c cubed. Well, 0 times c cubed is 0. So all of this goes to 0, and 0 plus anything is the other thing. So our simplified answer is just 9c squared minus 5c. And so we see how we've simplified this all the way down. The last example we're going to look at is a word problem. And so we're going to talk about the pieces that are involved in it and then how we get a simplified answer. So let's go ahead and look at that. So in example 3 of this word problem, we have to identify what information we're given and how we're going to combine it. And so the question says that the equations P equals 9m plus 105 and C is equal to 3m plus 62 represent the number of smartphones, P, and the number of gaming consoles, C, sold in M months at an electronics store. We want to write an equation, so that's our first direction, right? We are writing an equation for the total monthly sales, T, that's the letter we're going to use to represent that, of phones and gaming consoles. And then part 2, once we've got that, we want to predict the number of phones and gaming consoles sold in 8 months. So we got to first write this equation. Well, we're looking for the total monthly sales. So if I'm looking for a total, what operation are we doing? We're adding. And so I'm going to take
the phones, 9M plus 105, plus the cell phones, 3M plus 62,
and I'm going to add them together. And that's going to be equal to our T. Because again, it told us that T is the monthly sales of the phones and the gaming consoles. And so adding these together, 9 plus 3. And again, if you want to do it horizontally or if you want to do it vertically, your preference. Addition, I like to go horizontally. Subtraction, I normally will switch around. 9M plus 3M is 12M. And then the 105 and the 62. And so 105 plus 62 is 167. This cannot be simplified further. They're not like terms. So T is equal to 12M plus 167. We have completed the first part of this question. We have written the equation for the total monthly sales. But part B of the question says to predict the number of phones and gaming consoles sold in 8 months. And so if we're going to go for 8 months, that means our ebb has to be 8. And so we're going to plug that in. And so we're going to get T is equal to 12 times 8 plus 167. So T is equal to 96 plus 167. And so T is equal to 263. So what does that 263 represent? Well, we need a word answer to our question, of course. And so in 8 months, the store will sell 263 phones and consoles. Because remember, it's the total of the 2 products. And so again, remember that word problems require word answers. We need to apply this back. And that goes back to the standard we talked about at the start. We've got to apply this back to the context of the situation. So that's it for this section. If you got any questions, make sure you put them into the form, the lesson check form, and then I will catch y'all next time. Y'all have a good one.